Assalamu alaikum, students. This is lecture number 5T. This is the last lecture for the fifth part, in which we have been discussing the space harmonics. And for those who have a little back knowledge lost, space harmonics were those harmonics which were produced because of the winding distribution, which means that the stator winding that was distributed instead of concentrated. So you were having a lot of harmonics introduced, and the only way theoretically possible to actually make this harmonics disappear was actually having distributed winding, so that the G value can be equal to infinite, which means infinite number of steps. We have seen a lot of amount of space harmonics. We have seen the 6m plus 1, and we have seen the 6m minus 1, and those who still don't remember it, the 6m plus 1 was in the positive rotating direction, and the 6m minus 1, they were moving in the negative direction. That was actually the harmonics. So these were the harmonics, and this was the fifth harmonic, this was the seventh harmonic, and then this was the 11th harmonic, and then this was the 13th harmonic over here. This is a previous lectures discussion which we already know. Today, just in that 20-25 minutes, I am going to take to discuss the slip and the relative speeds of these harmonics over here. And just not to stress this lecture, I will be only considering the fifth harmonic, since this is going in the negative direction, and then you can repeat the very same for any of these, namely three other harmonics, the 7th, the 11th, and the 13th over there. So when we are talking about the slip over there, the first important thing over here, when I'm talking about the harmonic stuff means that you have to have harmonics in the stator, and since those harmonics will be flowing inside the stator, having their own number of poles, and the speed will be different, certainly depended by ns by the number of the harmonic in the denominator, and the positive and negative sign depicting that either it's moving in the positive direction or the negative direction, just shown over here like this. Then these harmonics are going to induce an EMF inside the rotor, and those rotor and the stator fluxes or MMFs, you can call them, they are going to actually move with the same speed. So now today in this lecture, I am actually going to the end of the lecture, we are going to just prove it that the fifth harmonic, since I am concerned about the fifth harmonic in this lecture, so the essence or the proof which I am going to do today is it that the fifth harmonic, which is flowing inside the stator, and the fifth harmonic which is flowing inside the rotor, and I will call them as the fifth harmonic stator MMF or the fifth harmonic rotor MMF. So these both MMF with respect to a common point, and since common point is u, because you will be standing stationary and stator is stationary, stator has only a revolving magnetic field, physically the stator is stationary. So this means that I am going to have both of these speeds relative to stator. So the first thing first over here, since I am talking about the fifth harmonic over here, so first of all, for the fifth harmonic, I am going to talk on the first of all find out the slip. Now if you remember the slip concept over there, in fundamental, slip was taken as, I'm just writing down the slip formula, slip was taken as ns minus nr divided by ns. So what was slip over there? Slip was actually the relative speed of the rotor, the synchronous speed, sorry, the relative speed of the synchronous over there with respect to the rotor, and dividing it by ns over there, this was slip over there. So now when I am talking about the fifth harmonic, so I am talking about the slip produced by the fifth harmonic. Sorry about this one. So slip produced by the fifth harmonic with respect to the rotor speed. So I am trying to find out over here in this one, we take the rotor speed with respect to the fundamental. Ns is here the fundamental. So now when I'm trying to find out the slip, this time my slip is going to be called as S5. You can call this one as S1 because whenever we were talking about induction machine, this was only the slip concerned. So we never used this one as subscript over there. This time I'm talking about S5, which is actually the slip produced by the fifth harmonic with respect to the rotor speed. Now the rotor is still going with NR speed, so that's not going to change. But here the same formula, now this time it is not ns over here when I'm going to write this formula over here. So first of all, let me do some steps over here. I know ns, it is flowing in this clockwise direction, and nr is flowing in this direction. So now at the very same time, let me use another color for this one. There is a backward moving MMF, which is ns by 5. Why backward? Because I just told you in the very start, I just revised it because the fifth harmonic is flowing in the backward direction. This negative sign was telling us. So this means that ns by 5 is going in the opposite direction, that is of ns. That's why it was producing that crawling effect in the braking region, if you remember that. Now when I want to find out S5 over here, S5, so I have to subtract this, what we did over here. If you see the slip formula, we subtracted ns minus nr. So here this time, what is ns over here? This is ns by 5, but this is flowing in the opposite direction. So now I have to make them both in the same direction, then I can subtract them. So what I am going to do over here, I am going to write this one over here as minus ns by 5. What does minus mean? I have opposite the direction. So this means that I can write this ns by 5 as ns by 5 and negative direction. So this is telling me that both ns by 5 minus ns by 5 and ns, now they are in the same direction. Now I can subtract them. So this will be minus ns by 5 minus ns divided, sorry, not by ns, sorry, this is going to be nr divided by minus ns by 5. This is the slip. So the slip formula is this. Now those of you who have a little bit problem with this and you don't want to write it in this way, there is another way. You can take it in this way. Now since if you see over here, this ns by 5 and nr over here, they both are going in opposite direction. So when you want to find out their relative speed, since they both are moving in the opposite direction, you have to add them. So ns by 5 plus nr divided by ns by 5. So this one and this one, they both are the same equation. So nothing changed over there. So I can use any of these equations. So I'm just write it down again just for brevity. You can write down the second equation or the first one. They both are the same because here everything is negative. Here everything is positive over here. This is not negative or something. This is just I wrote the tick mark over here. So this is ns by 5 plus nr divided by ns by 5. Now I can do some simplifications over here. This is since slip with respect to the fifth harmonic. So I can write this one as 1 plus 5 nr divided by ns. And now since I know already due to one formula that nr is equal to 1 minus s ns. This is formula is already known to you. So I can write this one as nr over ns is equal to 1 minus s. And I can put this one in this above equation. So S5 is going to be equal to 1 plus 5 and brackets open. So this will be 1 minus S. And now if I just do some simplification, this S5 is now equal to 6 minus 5S. And what is S over here? This S is the fundamental slip, or you can call it as S1 or simple S. It's totally up to you. But since you have been named this one from the previous courses as S, so no need to actually call this as S1 or something like that. Only S is sufficient. Now even whatever S you have, this is going to give you an S5 much higher than 1. Because even if your S is equal to 1, your S5 is going to be also equal to 1. So S5, as I told you previous lectures also, that S5 is going to be a very high value of slip, and that's why the copper losses, which are the rotor copper losses which are happening inside the rotor, they are going to be on the high side over there. So this is the slip produced by the fifth harmonic with respect to the rotor speed. Now the next thing which we have to do now is the speed of fifth harmonic rotor MMF. Now I have gone towards the rotor. Please see this thing very importantly with respect to rotor. So what I am doing, the stator produced this, or the stator distributed winded produced this fifth harmonic. Now this fifth harmonic has went inside the rotor and it is now producing an MMF over there. I want to find out its speed. Now if you remember over here, whenever it was fundamental talk over there, let me just talk over here on this side. So if you remember, what was the speed of the rotor MMF when it was fundamental? This was equal to 120 FR divided by P. Remember, this was the fundamental speed with respect to, no, this was not the actually the NR. Actually, in fact, let me just remove this. I can call it not NR effect. I can call it NS comma R. Now, what is NS comma R? This is the rotor MMF speed, because rotor is also going to have an MMF. One thing very important over here before I go on forward, stator is having an MMF which is moving with speed 120 F by P with respect to the stator, which is stationary. The rotor is having an MMF also, and it is going to move with the same speed that is of the stator. But when we are talking about the rotor MMF, the fundamental, with respect to the rotor, its speed is given as 120 Fr by P. And if you remember the previous knowledge, Fr was equal to S times F electrical. And what was F electrical? F electrical was the stator frequency which was being given by the supply, and in our case that was equal to 50 Hertz because we are in Pakistan. So this was for the fundamental. This was for the fundamental. Now this time I have to find out the speed of the fifth harmonic rotor MMF with respect to rotor. So what I am going to do now, you can write 1 over here as well because that is actually for the fundamental. Now I need to find out the MMF speed for the rotor, NSR, you can call it NSR, comma 5. So I am trying to find out the fifth harmonic which is flowing inside the rotor and its speed with respect to rotor. So the formula is going to remain the same, just like this. The only thing changed would be that 120 will remain the constant. The next thing, instead of Fr, because Fr was the rotor frequency and we assumed this one was the fundamental at that time. So that's why we had this formula of Fr equal to S times Fe. This time it will be equal to F5, or you can call it F5R, which means the rotor fifth harmonic frequency which is inside it divided by, now if you remember in stator when it was fifth harmonic, you created 5 poles over there, 5 times the pole over there. So here in the rotor also you are going to have 5 times the poles created. So in the denominator you will have 5p over here. I'm again repeating this. This is very important one. Here on this side, right side over there, this is the formulas for the fundamental. Rotor has also an MMF in the fundamental, and if we want to find out its MMF speed with respect to rotor, that is given as 120 Fr by P. What is Fr? Fr is the frequency of that electrical signal inside the rotor, the fundamental one. And what was that formula for? Fr was equal to S times Fe. Now since now the rotor also has a fifth harmonic over there, and I am now trying to find out the speed of that fifth harmonic rotor MMF with respect to rotor, same formula. The only thing changes, this time it will be F5R, or you can call it Fr comma 5. It's totally up to you. Different books can have different nomenclature on this one. And in the denominator you will have 5p. Why? Because this time whatever number of poles is the standard. Supposing you were having a 2-pole machine, so this time for the fifth harmonic the number of poles will increase by 5 times because this is the fifth harmonic. I don't need to. Those who can't understand it, please go to lecture number 5b or I guess 5b. You can find out that idea that why the number of poles are going to be increased over there. Now since this is NSR comma 5 which is equal to 120, now instead of this F5R, now F5R I can write it down. F5R is going to be equal to S5, and here this will be Fe. What is S5? I have already found out S5 over here. So this is 6 minus 5S. So this means I will just straight away write down over here 120 into 6 minus 5s into F electrical divided by 5p. So this is my NSR, 5. Remember, when it was simple NS, that was the synchronous speed of the stator magnetic field. When I'm talking about NSR, this is the rotor magnetic field, which is also there. But this time I'm talking with respect to the fifth harmonic over here. So fifth harmonic speed is going to be equal to 120 6 minus Fs Fe. Now, out of this term, if you see this one, 120 Fe from the numerator, and if you take P over here, what was Ns called as? Ns was equal to 120 F, or simple Fe. Fe is the grid frequency which you are supplying, and what was Ns. So this means I can write down this equation, NSR, 5 equal to 6 minus 5s Ns by 5. So this is my rotor MMF speed with respect to rotor. Please remember, I am trying to find out the fifth harmonic rotor MMF speed with respect to rotor. This is still with respect to rotor. I have not still taken it to the stator side. In the next step, I am going to take it towards the stator side. So the next step which I am going to do now is actually the speed of fifth harmonic rotor MMF with respect to stator. Now, what I mean by this, I am trying to find out the same rotor MMF fifth harmonic which is flowing inside the rotor, and I want to now find its speed with respect to stator, which is stationary. So you are stationary over there. So now, very simple thing. First of all, you have to write down the first thing, which is actually the speed of the fifth harmonic rotor MMF with respect to rotor, and add it with the speed of the rotor, because rotor is already rotating with the speed nr. So this is this equal to, so I will just write it down again over here for those who still can't understand. So this is speed of the fifth harmonic rotor MMF with respect to rotor plus. Now this is going to be the speed of the rotor, physically speed, with respect to stator. I hope you are getting this. So when we want to find out the speed of the fifth harmonic with respect to stator, or with respect to us, because we are going to be stationary, standing aside the stator over there, or standing beside the machine, so we need to add. So what is the first term? First term is the same thing which you just found out. This is 6 minus ns. Oh, sorry, 6 minus 5s. Sorry about it. So this is 6 minus 5s ns divided by 5. So this is the first term over here. And then what is the speed of the rotor with respect to stator? This is nr. So this is just to add it over there. Now, when I want to add this one, so this would be equal to, I will add this one. Now one problem over here when I am doing this one, remember this thing. What is the speed of the fifth harmonic rotor MMF with respect to, if I go back on my diagram, this diagram, the rotor MMF was moving opposite. Okay? So this means when I have to add these two together over here, I will have to put a negative sign over here. Why is that so? Let me just clear it again. If this is the rotor is rotating physically with speed nr, no problem. But at the very same time, the stator MMF was rotating with speed ns. The stator produced a magnetic field that was ns by 5, that was moving in the opposite direction. The same stator MMF produced a stator magnetic field inside the rotor, and we called it nsr by 5, which was moving in the opposite direction. So now I have to add this speed with this speed. So I will have to make one negative sign and then add together over there. So I have put this negative sign over there. In fact, let me rub this one over here, and so this is this negative sign over here, like this. So now I have to add this, so I will just open this. Remember this both are moving in the opposite direction. So now when I have to make them add together, I have to make them in the same direction so I can find out the net speed. This is very important, because if they both are moving in opposite direction, here I am trying to find out the net speed or the relative speed with respect to the stator stationary. So when I will open this, this will be equal to minus 6 ns by 5. Since minus and minus, this will become plus, and since 5 and 5 will cancel, so this will become SNS plus NR. Now, what is NR? We have done this previously just now. What was NR equal to? This was equal to 1 minus S into NS. So I will just put this in this equation. So this will become minus 6NS divided by 5 plus SNS, and instead of NR, I will just put 1 minus SNS. So this will become NS minus SNS. This is the line over here. So now this SNS and this SNS cancelled. So what I have now, I have minus 6 NS by 5 plus NS. And if I formulate this, this is equal to minus NS by 5. So what is this? This is the speed of rotor fifth harmonic MMF. This is MMF with respect to stator. And I just told you over here, what was speed of the NS? That was NS, rotor magnetic field, the fundamental, and that was going in by NS minus 5, or if I want to take it negative, this will be in the same direction, and I have found out this one, so this is minus N by 5. So what I mean by this, the speed of the rotor fifth harmonic MMF with respect to stator is minus N by 5, and the speed of the stator fifth harmonic MMF with respect to stator. We already know that this is equal to, we already know this formula. This was equal to this was NS5. We already know the formula. This was equal to 120 F electrical, and we divided it by 5P. And what was this equal to? This term over here was equal to NS, so we can write it over here as NS by 5. And we have to add the negative sign. Why negative sign? Because we know the fifth harmonic, it is moving in the opposite direction. So this one and this one. So this is just a proof telling over here that the speed of the rotor fifth harmonic with respect to stator is minus ns by 5, and speed of the stator fifth harmonic MMF with respect to stator is also minus ns by 5. So whatever harmonic you take, either you take the fifth harmonic or the seventh harmonic, they will have the same speed with respect to the stator, which is actually the stationary part over there. So you can repeat this all stuff which we have done over here with respect to the seventh harmonic over here as well. But remember one thing, that when it will be seventh harmonic, it will not be flowing in the opposite direction. It will be flowing in the same direction. So this negative sign minus which we have just started, so I did the difficult part over here. You can do this one yourself for the seventh harmonic. I will just write down the end results over here for you, so it's easy for you. You just write down the end results over here. So for the seventh harmonic, the S7 which you are going to find out is going to be 7S minus 6, and when you are going to find out NSR comma 7, which is actually the rotor MMF speed, rotor MMF seventh harmonic speed with respect to rotor, this will be equal to 7S minus 6 into NS by 7. So this is going to be this one. And when you are going to formulate this same statement, you will find out that the speed of the rotor seventh harmonic with respect to the stator is going to be ns by 7, and the speed of the stator seventh harmonic with respect to the stator is also going to be ns by 7. So you can just prove it yourself. You can do this, the same stuff. It can be asked in the exam for the fifth harmonic, the seventh harmonic, the 11th harmonic, and the 13th harmonic. These four harmonics are the most important ones, and they normally create the most of the problem for the machines over there. Now let's do one example or numerical over here. So this will not take much time. So exam numerical can be there. Now what is the statement of the numerical? I'm just going to write on the data. It's a three-phase machine, and it is a 50 hertz machine, certainly, because we are in Pakistan, and the speed of the rotor has been given as 1440 rpm. Now the speed of the rotor has been given, which is you are actually getting on. Now whenever the speed of the rotor is given, I guess this is simple common sense over there. The nearest synchronous speed, that is 1500 rpm, and the number of poles we are getting is 4. So this is simple common sense over there. Whenever this data has been given that it's 50 hertz, the rotor speed has been given, because this is the fundamental rotor speed over there. So this is 1440 rpm. The nearest synchronous speed is 1500 rpm. So number of poles are 4. If it was something 2800 something or 2900 rpm, then ns would have been 3000 rpm and poles would have been 2. Now what has been asked in this question, let me write down the two statements over there. It has been asked, what is the relative speed between fifth harmonic field and rotor? So this is the second thing which we have done over here. If you go back over here, what was the speed? The speed that you found out, this one over here. So this has been asked over there. Now you don't need to every time remember this formula, because you have to do it over there. So this can be done. I will just show you, instead of proving it again and then doing it. I will just write down these first two statements, then I will solve this in front of you. And second thing, what is the slip of the rotor with respect to fifth harmonic field or MMF, whatever you want. Now the B part is very simple. I guess no need to do any fancy stuff over here, because S5 already we know the formula. Even if you don't know the formula, you can just do it again yourself, because we know fifth harmonic is going in the opposite speed. So this is minus ns by 5 minus nr divided by minus ns by 5. You plug in the values over there. How? Because you already know ns, just make it divided by 5. You already know nr, and you will find out the formula. You can do the mathematics yourself. I'm leaving that to you. So the answer is simple, 5.8. So you can see the slip that is coming out is very high. It is now don't be afraid of this one, because S5 is the moving in the opposite. The fifth harmonic is moving in the opposite direction. So technically its slip will be high. So the fifth harmonic losses which are going to happen inside the resistance of the rotor. So if you remember your PRCL, that was the rotor copper losses, they were equal to S times P air gap. So when you are trying to find out the rotor copper losses because of the fifth, so you will put on S5 into P air gap. So this is actually going to tell you a lot amount of losses which are going to happen because of the fifth harmonic over there. Now coming on to the A part, because A part is also asked over here. Now if you want to find out the simple thing, instead of remembering anything formula over there, very simple, you need to find out NSR5, which means you are trying to find out the rotor MMF fifth harmonic inside the rotor MMF with respect to the rotor. So the formula was very simple, that was equal to 120 F5 divided by 5P. Now what was F5? If you remember, F5 over here would be equal to, if you B part was not asked to you, then this was equal to S5 into F electrical over there. Now since S5 is already there, so S5 is already known to you, so I just need to put in the values over here. So this will be equal to S5 into F electrical, and this will be equal to 5 into P. And if I put in plug in the values over here, this will be 120 into what is S5, this is 5.8, and what is electrical frequency, this is 50, and here this is 5 into 4. And if I just do the mathematics myself, this is equal to 740 rpm. Now you will be amazed at this thing, how the speed is higher than the actual rotor speed. Please remember, this speed is opposite. This is very important. This is opposite to the direction of rotor. Why? Because ns by 5, I told you, the fifth harmonic that moves in the opposite direction. That's why its crawling effect was happening in the braking region. So this is very important over there. So this is the numerical. I hope this was easy for you, and this is a very small topic, because sometimes these questions are asked in exam, that the fifth harmonic and the seventh harmonic and all this. Please try to do this for the 7th harmonic, 13th harmonic and 11th harmonic, because these 4 harmonics are the important aspects asked in exam, or the important harmonics which are going to actually do any problems for the machine. Thank you for this one, and I hope space harmonics are complete from my end. You can do this 7th, 11th and 13th harmonic stuff yourself, or whatever their slip and the relative speeds are concerned. I hope you have the idea how relative speeds are calculated, and in the next lecture I am going to talk on the slot harmonics. Now, what are slot harmonics? Just a 1 minute answer on this one. Slot harmonics are those harmonics which are going to be produced because of the stator slots or the rotor slots. So they are going to produce their own harmonic, and their number is going to decide that which harmonic is actually going to be present or not. We will talk in much detail in the next video. Thank you for watching this.